I'm Anil Kumar. Welcome to my series on graphs. In this video, we'll try to understand speed-time graph, and from the given graph, we'll sketch acceleration time and distance time graphs. The question here is, for the following speed-time graph, sketch a possible acceleration time graph, sketch a possible distance time graph. Let's first try to understand the given graph. It is velocity, which is same as speed, and time. Say velocity, we are also worried about the direction. Now we are given here that object starts from the starting point, which is here at the origin. So velocity is 0 at t equals to 0. It reaches a maximum velocity of 30 meters per second after a period of, total duration of this is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are unit seconds, right? So that will be 3 seconds, and this will be 2 less than 10, 8 seconds, correct? So we can actually describe this that the object starts and it accelerates at a constant rate, increasing the velocity from 0 to 30 meters per second in 3 seconds, right? And then travels at a constant velocity, 0 acceleration, for 5 more seconds, and then return back to the starting point very fast within 2 seconds, right? So the velocity drops from 30 meters per second to 0 within a period of 2 seconds. That is deceleration. Perfect. Now with that information, let us now talk about sketching the acceleration. So acceleration is rate of change of velocity, right? So it is rate of change of velocity. Now both acceleration and velocity have direction. So a negative value will indicate the opposite direction. So in this particular case, there are 3 legs in which the acceleration is changing. So we'll define them with our points A, B, and C. So in the very first stage, where the acceleration is constantly increasing, right? Velocity is constantly increasing. There's a constant acceleration. Let's find acceleration in the duration 0 to a. When we say rate of change, that means the value at the end minus value in the beginning. We have 30 meters per second minus 0 meters per second divided by time, which is 3 seconds minus 0 seconds, correct? So that gives you 30 meters per second over 3 seconds. And so we get 10 meters per second square, right? So meters per second square is the unit for acceleration. In the second interval, which is from A to B, the change in velocity is 0 since it remains 30 meters per second. Is that clear to you? And the time changes from 3 seconds to 8 seconds. We'll do 8 minus 3 seconds. We get 0 over 5 meters per second square, and that is 0. In the third interval, which is from B to C, we observe that the velocity changes from 30 meters per second to 0, so we'll get 0 meters per second minus 30 meters per second divided by 10 minus 8 seconds, correct? So we get minus 30 meters per second divided by 2 seconds. That gives us minus 15 meters per second square. So these are the values in the given intervals which we need to now plot to get sketch of acceleration time graph. So let's write acceleration time graph. So we have to say 10 meters, 0 and minus 15. So let's make a scale for this. We are going up to minus 15. So looking at this, we'll write this as 5 units, right? So 5 units, this will be minus 5, right? So we are now writing acceleration A in meters per second square along the vertical. Time we are keeping same. So in the first interval, acceleration is 10 meters per second. So let me use a different color to sketch it. 10 meters per second is constant in this interval for the first 3 seconds. So that is our 10 meters per second, correct? Then we have 0 meters per second. So that is 0 meters per second, clear? And then we have minus 15. So 5, 10, 15 in the last phase. So these horizontal lines represent the acceleration for the given situation. Is that clear, right? So we have this as minus 15, right? This is minus 10, and that is 10 meters per second square for us, right? Now let's talk about distance time graph on a fresh page. So now let's sketch a possible distance time graph for the given velocity time graph. The object moves initially with 0 velocity, increasing it to 30 meters per second within a period of 3 seconds, right? And then 1, 2, 3, 4, 5 seconds, that means 8, it moves with a constant velocity. So even when the object is moving at a constant velocity, distance is increasing, remember that. Now here, the object comes back to the starting point. The displacement is 0. However, the distance further increases. It traveled more distance, correct? So now, keeping that in mind, let us try to sketch the distance time graph. One more thing to remember is, when the velocity is increasing, then the rate of change of distance is also increasing. So we have a non-linear graph, right? So in the portion where we show kind of like this, the distance graph will be increasing at a non-linear rate. So in this portion, in the first portion, the distance time graph will be rapidly, distance will be increasing, right? Now at this stage, the velocity is constant. So the distance increases at a constant rate and it will be a straight line. So whenever you're talking about non-linear curves, it could be in this fashion or in the other way, depending on whether it is slowing down or speeding up, right? So negative speeding is also speeding, correct? So that distance will also be like shown as a curve, right? Now, let us see how we are going to display this on the graph. So first, let me divide this particular portion into groups as we did last time. Let it be O to A to B, and B to C. Distance is basically area under the graph. So let's find the distance traveled from O to A. So we'll calculate the area under this graph. So that is to say, we'll find the area of this portion, right? So area of portion, that will give us the distance, maximum distance covered at this point, that is in first 3 seconds, right? So in first 3 seconds, area A1 in this graph is A1, area of the triangle, which is half of base is 3 seconds, right? So we'll write 3 seconds times height, which is 30 meters per second. 30 meters per second, right? So 3 goes 15 times, and this is 45. You can always use calculator, right? So we get 45 meters as our unit for this. you can clearly see that the unit seconds and seconds cancel, so we're left with meters. Perfect. In this portion, the distance traveled is how much? It is a rectangle. We're talking about this area now from A to B. So it is 5 units in seconds, right, times velocity is 30 meters per second. So we get 5 times 30, which is equals to 150 meters. Now the third area A3, let's calculate this distance also, is equal to, it's a triangle, half, base is 2 seconds, right, 2 seconds, times height, which is again 30 meters per second. So 2 and 2 cancel and we get 30 meters. So we get 45 meters in the first leg, 150 meters in the second, and 30 meters in the third leg, right? So the distance is always increasing. Let's plot these points. So we are looking into the points which are for us at 3 seconds, distance is 45 meters. Now at 8 seconds, distance will be combination of these two, right? So it's 150 more, that makes it 195. And then at 10 seconds, the object moves further away by 30 more meters. So it will be 5, 3, 12, 2, 225 meters, right? So we're talking about now time and distance, correct? So we have to plot these points. So we have to plot 45, 195, 225, correct? So let us draw it here. So we'll take this as our distance and time. So time will be shown on the horizontal as we did earlier. We'll keep the same time as we did earlier in seconds, same scale I mean. But for distance we have to define a new scale, right? So let's say if you go by 50, 100, 200, 250, that should be fine, right? So we will go with 50s, rather 25s. So I'll write here 50, 100, 150, and 200. So these are distances. So we'll say distance in meters, right? So that is the vertical axis. Now time in seconds. So that is same as we have 3 here. So let this be, okay, so 3, 1, 2, okay. So that is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I've marked those which are of prime importance. Now at 3 we have 45. So at 3 the point 45 will be close to, this is 25, right? So at 3 it will be somewhere here. Then at 8 we have 195, close to 200. So at 8 it is close to 200. Let's say this is our point, but less. And this is 225 at 10, so it reaches there, correct? So these are the 3 points, starting with 0, of course. Now, as I was saying, shape of the graph is very important. So let's look into the shape. Since the distance is increasing all the way through, we'll go and at a constant rate. So that is, rate of change is increasing. So if I draw a tangent here and there, is steeper as we move forward. So that indicates higher velocity. Now from here to here, it is a constant rate, so that should be connected with a straight line. So this is a straight line for me, correct? Now again, the distance is increasing, right? In fact, it is even faster, right? So it is, So it is increasing, so we'll again do like this. It decreases, velocity decreases from higher value to lower, so it actually goes kind of like this, not this. Okay. So in the later half, the velocity decreases from 30 to 0, distance increases, but at a lower rate, right? So this portion will be kind of like this. So the distance is increasing, but at a lower rate, right? So it drops from this slope, which was 30, to 0. So it will be kind of like this, tapering down, as you can see, a horizontal line here at the tip, right? So it becomes almost 0. So it will be almost 0 when we start with, you see, just kind of like this, and end also with 0. That means if I drop a tangent here, it will be horizontal. So that's kind of important to understand. And the points mentioned are the given here, right? So this point for us is 345. The other point is 195. And the third point is 225. On this distance time graph. Perfect. So that is how we'll get our graph. So I hope the concept is absolutely clear. It is kind of important to show the gradient here in the form of a curved surface so that we can represent the increase from 0 to 30 for velocity. A straight line indicates a constant velocity of 30 meters per second. And this curve, which is parabola opening downwards, indicates that the velocity decreases at a rate which is constant. Right? We worked in acceleration as 15 meters per second, right? From 30 to 0 meters per second. Perfect. So that is how we should be drawing these graphs from velocity time graph. I hope the concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.